In this video, we are going to see about NodeJS event model. So first we are going to see about what's the difference between the traditional model and the NodeJS event model. NodeJS provides the scalability and performance by using its powerful event-driven model. NodeJS application that uses the single thread event-driven model. So here the NodeJS application uses single thread to handle the multiple client requests. So for handling multiple client requests concurrently with this single threaded model, Node.js implements thread pool. So this actually runs on background. This contains the multiple threads for handling the different requests that not affect the main thread. So that is actually the concept of Node.js event model that uses the single thread for handling the multiple requests. In background, this will be execute the thread pool. So that is used to handle the external resource request. So first we compare the traditional event model and also the Node.js model. So traditionally we are using the multi-threaded model. So in the multi-threaded model, so whenever the request comes, the request is assigned for the particular thread. So that will complete that particular request. So when a request comes, so that is actually assigned to a particular thread. The thread handle the request until it sends the response back to the client. So that is the concept of multi-threaded model. So each and every request that is assigned with the dedicated thread that actually handle the client request concurrently. So for example, so if you want to process the two requests, one is get file and another one is get data. So get file that is used to access some information from the file, and the get data that is used to get the information from the database. So in the traditional model, when the request comes, so here request for example, so here the get file, now the thread 1 that is assigned to handle the particular request, so this thread 1 that is blocked with that request until we are send back the result back to the client. And when you receive the second request get data, again the separate thread is assigned to the get data request, and this is dedicatedly for this particular request, and this is blocked with that request until it send back the result back to the client. So here this get file that actually consists of multiple subtasks. So for getting the information from the file, first we need to open file using the particular command, then we need to read the information and send back the information to the client. So normally this is the IO, even though the particular thread that is blocked with that request until the response sent back to the client. So this is happen in the case of multi-threaded model, that is traditional multi-threaded model. Whenever the request comes, a separate thread is assigned for a particular request, and that is blocked with that request until the response sent back to the client. So now we can see about this Node.js event model. So Node.js actually handle this differently. So whenever the request comes, so that is added into the event queue. The event queue that actually runs a single thread. That single thread pick that event, and that actually classify that event into the two types, whether the event is a blocking event or non-blocking event. If it is a blocking event, so that is transferred to the thread pool. So here that thread pool that consists of some background thread that is handle the request. Now the main thread that is again go and pick the next request. So here the sub functions are added with the callback for getting the good performance. So for example, so here we are having the two requests, get file and another one is get data. So here the sub function, so in the get file is a main request. So this consists of different subtasks. That is, first we need to open the file. So this is added with the callback. Callback is nothing but that we are called inside the another one function. So then while we are after opening the file, so we need to read the information, then reading the file, send back the result. So every subtask is here added with the callback. So when this is the event queue. So here we are adding the subtask as a callback, and the event queue that consists of single thread that will be pick the request from the top of the queue and process that one, and if it is completed, send back the result to the client. If it is contain another callback that is added with the back to this queue. So likewise, that is actually the event model working in the Node.js. So here the subtask is added with the callback, and all the subtask is added with the individual function in our individual request in our event queue, and the event queue that consists of only one single thread that is pick up the request and handle that request. So here first we have to see about what is blocking request. So blocking request means that stop the execution of the current thread and wait for the response before continuing. That is normally called as blocking request. So the blocking request that actually block the main thread, and they may complete this task by using some external resources, but the main thread is blocked until get the response. So for example, reading a file, querying a database, socket request, accessing any remote. So here the Node.js that is handle this blocking request in a separate way. So here we are having only one thread for handling the multiple client request. So here when it receive any blocking request, so that is transferred to the thread pool. So Node.js implement thread pool in a background. So when it receive any blocking request, so that is given to the thread pool. So this actually prevent the blocking IO holding the rest event in the event queue. So when it's executed, again it is added into the event queue and the further processes proceed. So that is happen in the case of Node.js. So here when the Node.js application, so this will be receive the request, and if it is consist of subtask, that is added with the callback. And here the event queue, so we are having single thread, that is the event loop that is runs on this event queue, and it pick the single task from the event queue, and it find out whether this is the blocking request or not blocking request. So if it is a blocking request, that is transfer the blocking request to the thread pool. Now the event loop that is pick the next tag from the event queue, and again check if it is a blocking or non-blocking request. If it is a non-blocking request, execute the particular task and send back the response to the client. If it is a blocking request, that is added to the thread pool. So here the thread pool that contain the different thread for different operations. For example, it has the different thread for performing the IO operations. So like that, this will be has the different thread. So using that particular thread pool execute that task, and that is added into the event queue. So finally the event loop pick up the task and verify if it is executed, that send the result back to the client. So this is why the node event model executed. So here while we receiving the request, so here all the subtask is added with the callback. Callback is nothing but that is a task that is executed inside the another one task or another one function that is called as callback. And here the event queue, so we are implementing the single thread using this event loop, and the event loop that runs on event queue. So this will be pick the first task or first request from the event queue and check whether this is a blocking or non-blocking request. If it is a blocking request, that is added to the thread pool, and this is not actually blocked here. After this request is added to the thread pool, now the event loop come and pick the next tag and check whether it's a blocking or non-blocking. If it is non-blocking, execute immediately and send back the result to the client. Now this blocking request that is handled by the separate thread inside this thread pool. So likewise, this Node.js event model handle the multiple requests. So after finishing this task, this is again added to the event queue, and the event loop that pick the task from one by one, and if it is non-blocking, execute this one, send back the result to the client.